Okay guys, so now let's continue with the argument of complex number, which also known as theta. So as we know, there are four formulas for our theta, and they are depends on which quadrant does our point of complex number lies on. Okay, so as you can see, there is alpha over here. So what is alpha? Alpha is the reference angle, which equal to shift tangent modulus of b divided by a, which is b is the imaginary part of the complex number and a is the real part of the complex number. So there are two important things that you have to remember. The first one, your calculator must be in radian mode, and the second one, you need to take 4 decimal places as your answer. Okay, so let's try these two examples over here. So the first one, we have z equal to 5 plus 2i. So in this case, our a is equal to 5 and our b is equal to 2. Okay, so before we find the argument or theta, we need to know the basic angle first. So based on formula, we just insert our b and a. So since the value of b and a is already positive, so we just directly insert the value and we're gonna get 0.3805. Okay, so now for the argument or for the theta, so we need to identify which quadrant does our point of complex number lies on. So the x-axis is for the real part and the y-axis for the imaginary part. So for the real part we have 5 somewhere over here, and for the imaginary part we have 2 somewhere over here. So we need to use the formula in the first quadrant, which is theta is equal to alpha. So our final answer is equal to 0.3805. Okay, as simple as that. Okay, so now let's try another example. So for this case, we have a equal to -5 and our b is -2. So for our reference angle, we need to take the modulus of -2 and -5, which gives us shift tangent of 2 divided by 5, which gives us the same answer from the previous one, which is 0.3805. Okay, now for the theta or argument of the complex number, we need to use the formula from the third quadrant, because as you can see over here, the real part is -5, which is somewhere over here, and then the imaginary part is -2, which is somewhere over here. So we're gonna need to use the formula from the third quadrant. So our theta is equal to -pi minus alpha, so -pi minus 0.3805, which gives us -2.7611. Okay, so that is how we find the argument of complex number or theta.